Hello students, greetings of the day. In last lecture, we have discussed the functions in C++. So, in today's lecture, we are going to discuss another topic, that is objects and memory requirements in C programming or in object-oriented programming. So, today we are going to discuss this topic with respect to the objects and memory requirement. For that purpose, we are just going to discuss that how the objects are created and how the objects are declared, and at the time of that object declaration, how we are going to allocate the memory for that particular object. So that we are going to discuss, and we will discuss that how the memory requirements are going to be fulfilled by that class or by that object. So we all know that C++ is going to allow the defining the static data members within the class by using the static keyword. Actually, these static data members are the use of static keyword that we are going to discuss in our next session or in our next class. At that time, you will get clarified, or you will get the clarification that how actually the static member functions and the static data members are going to be declared and defined. Right? But with the help of these static data members within the class, we are going to define these static data members, right? By using that static keyword. Whenever we are going to have these static data members in our class, we should have some things in our mind. The first thing that we should remember that irrespective of the number of objects that we have created, only a single copy of that static member is created in a memory. Means whenever we are going to create such a kind of static data members, number of objects that we have created is not going to matter. We have created so many objects, but only one single copy of that static member is going to be created in that memory. Means if I have created 5 members, if I have created 10 static members, it doesn't matter. It is going to create only one copy of that static member, data member at our memory. So all the objects of a class are going to share that static member. Means every member or every object of that class that we have created is going to share only that static memory that we have created. Then third thing that we should remember, that is all these static members are going to initiate to 0, right? All the static data members are initiated to 0 when the first object of that class is created. Means we are just going to have the constructor, right? We are going to call it as a constructor. Means if I have defined a particular data member as a static and I am going to create the object for that class, at that time, at the very first time, that first object that I have created with the help of that class name, at that time, that static data member function or that static data member is going to initialize with the value 0. Okay, means the value of that static data member is going to be initialized as a 0. Then fourth thing that we should remember, that if the static data members are visible only within the class, but their lifetime is the entire program, right? Such a kind of static data members that you are going to declare within the class are visible only within that class, right? But the lifetime that data member is having is through the entire program. So these are the 4 important parts that we should remember about the static data member. The first thing is there, that is the static data members are irrespective of the number of objects created. Means whenever you are going to have the static member data member, the only single memory is going to be created. Only single copy of memory is going to be created irrespective of the number of objects created. Then second thing that we should remember is the class, all the objects of class share the only static member. Then third thing, that is the value of that static member, data member, is going to be initialized to 0 whenever we are going to create the first object for that particular class. And the last thing that we should know, that is the static member functions or the static data members are visible only within the same class, right? Only within that class. But the lifetime that they are having is throughout our entire program, right? So this is nothing but the static data members that we can use for the memory initialization or to have memory requirements. Then next, according to this, we can just initialize the or we can just allocate the memory with the help of this static data members. We are also having some different techniques, right? Many times we are not aware that in advance that how much memory we just have to allocate or we will need to store that particular information, right, in a defined variable, and in the size that of required memory can be determined at the runtime. Right? So many times, number of times whenever we are going to write down the programs, we are not aware that how much memory we just have to allocate for that particular defined variable, right? And we are also not aware that how much size that we will require for that memory. And that can be defined or that can be known at the time of runtime. Whenever we are going to execute our program, at that time it can be clear that how much memory will be required to save that information or to store that particular information with the help of that defined variable. So in such a cases, what we are going to do, we can allocate such a memory at runtime with the help of heap, right? For the variable that we are having by using a special operator in C++, which returns the address of our space allocated, right? Means in such a cases, whenever we are not aware that how much information we need to store at our memory location, that we are not aware of the size of required memory, at that time what we are going to do, we are just going to allocate the memory at the runtime, right? By using the heap concept, by using the variables, right? Within the heap for the variables that of given type, right? And for that purpose, we are just going to use some special operators. In C language, we all know that for such a kind of runtime memory allocation. In C programming languages, we are aware that we are using the calloc and malloc, right? Same like that, we are having a special operator in our C++ programming language, which is going to return the address of that space allocated, right? So with the help of these operators, we can just have the runtime memory allocation in our C++ program. So this operator is known as new operator, right? Same as your operator that you have used in your C programming language with scala and malloc, you are going to use here operator which is known as new operator, right? So if we want to allocate such a runtime memory at the time of execution of program, at that time we can just use this new operator. By using this new operator, we can just allocate a memory to particular variable of a given type at the runtime. So if we are not in need of such a type of dynamically allocation of memory anymore, at that time we can use the delete operator. So there are two operators, new operator to just allocate the memory dynamically, and in case we have allocated the memory dynamically, but in our program we just don't need or we want to free up that space, right? We are not going to use the dynamically allocated memory anymore. In such cases, what we are going to do, we are just going to use the delete operator, and with the help of this delete operator, which we can just deallocate the memory that is previously allocated by the new operator. Yes, the memory that we have allocated dynamically with the help of that new operator is going to be deallocated with the help of this delete operator. Okay, so there are two operators that are going to be used to allocate memory dynamically and to deallocate the memory dynamically, and these operators are new operator, and the second one we are having is delete operator. Okay, so this is nothing but the memory requirement, that how we are going to allocate the memory for particular variable or for particular information that we are having in our program. So here is one example with the help of which we can just understand that how we are going to use or how we are going to make use of that new operator and that delete operator. Okay, so with the help of this program, we can understand that we are having one class box in which we just have the public specifier, data specifier, or member function class specifier, and in that we have one constructor, right? That constructor just specify or just print out the message that constructor is called, and we are having one destructor, that is the box, and that displays the message that is destructor is called. So this is nothing but the class that we are having, which is having two member functions, that is nothing but constructor and destructor. Both are constructor and destructor, right? So in main function, we are having main function in which we just have created one object, pointer object that we are having, my box array, right? And we just have initialized or we just have created the object of 4 size, right? Here we are not aware that how much memory that we are going to allocate for this particular object, right? So we are going to allocate that memory dynamically with the help of what? This new operator, right? For this new operator. So here we are going to have the array of objects. So here we are going to create the array of 4 objects that we are having, right? So what is going to be happen for this array of 4? This constructor is going to be called 4 times, right? So the output will be constructor is called for your first element, then it is going to be called second time for second element, third time for your third element, and fourth time for your fourth element, right? So we are just going to have a memory for these 4 elements, right? Now here we are only having the constructor. If we are having some data members, that data members are going to be initialized for particular values, and some memory is going to be allocated for those data members. Okay, so in a such a way that we are just going to allocate particular memory for that data member, right? And this is nothing but the use of our new operator. So for particular element, we are just going to allocate the different memories, right, with the help of this new operator. Then we are having delete operator. Here in delete operator, we are just going to free up this space that we have allocated with the help of new operator. That how we can do? We are just going to use this delete and the object name, right? My box array, which is going to delete the array, right? With the help of this delete operator. So whenever I am going to call this delete, it is going to call this destructor, right? Whenever I am going to call this delete my box array, it is going to call the destructor that I have defined within my class. So how it is going to be display the message? The first time, obviously, the every object that I have created, 4 objects that I am having, every object is going to be deleted. So for the first, it is going to delete. The constructor is called, destructor is called for first element. Then for second element, we are having destructor is called. Then for third element, again it is going to display the message that is destructor is called. And for your last element, element number 4 that we are having for this new object, my box array, that is going to be deleted with the help of this delete keyword or the delete operator. So this is nothing but we can operate with the help of this new and delete operators for the dynamic memory allocation and dynamic memory deallocation. Okay. So this is all about our today's topic. Okay. So in today's topic, we just discussed the objects and the memory requirements that we are having for our objects. Okay. So in today's session, we are just going to stop here. We are going to end our session today. In next session, we are going to discuss the another topic from our object-oriented programming. Okay. So today we are going to stop. Thank you. Thank you.